very well warm welcome for all of the aspirants. Okay. So welcome to the ACE Preparation League. Today we will be discussing some of the expected questions from the topic Theory of Machines. So in this subject we will be discussing the questions from analysis of mechanisms, next would be gears and gear trains, the third topic would be flywheels, next would be governors. Okay. So today we will be seeing all these 4 topics and some of the possible questions, right. So let us start the session. Okay. So here a mechanism is given to you. For this mechanism you are required to determine the degrees of freedom. Okay. So in the analysis of mechanism, one of the possible questions what you are going to get is from degrees of freedom. Okay. So let us do that, guys. So here in the figure the link number is already given to you. Okay. So let us write the number of links. Right, here ground will be counted as link number 1. So link number 2, this is the shorter one, that is link number 2, 3, 4, 5, 6, 7 and 8. Okay. So total there are 8 number of links, or I would say here if you see carefully, link number 5 is a ternary link. Link number 5 is a ternary link. So here this 8 can be split into 7 binary links. 7 binary links, okay, and the last one, that is link number 5, is a ternary link, and 1 ternary link. Okay. Now for this we are required to calculate or count the number of joints. Okay. So let us count the number of joints. Okay. So here between link 1 and 2, that is the shorter one, there is a revolute pair formed. So I will number this as R1, 2. Okay, that is the revolute joint number 1. Similarly, guys, at 2 and 3, there is another revolute joint present, that is R2, 3. Right. Similarly, here at this node, which is connecting the link 3, link 5 and link 4 together. So at this node you will be finding 3 links present. So 3 links can be joined with the help of ternary joint. Okay. So this ternary joint is equivalent to 2 binary joints. Ternary joint is equal to 2 binary joints. So here I will write there will be 2 binary joints. So one of the joint would be R3, 4, R3, 4, revolute joint between link 3 and link 4. Similarly, there will be another joint between 4 and 5. Okay, there will be another joint between 4 and 5. Now, you will put a question that, sir, there will be another joint between 3 and 5. I am sorry to say this is wrong. Okay, so I am assuming that link 3 is in the front, followed by link 4 is on the back side of link 3, and on the back of link 4 there is link 5. So there I can see contact between link 3 and link 4. There is a contact between link 4 and link 5, physical contact, but there is no physical contact between link 3 and link 5. So there is no pair formed between 3 and 5. So please be careful while counting the number of joints. Okay, please be careful once again while counting the number of joints. What I have written, this is wrong. Okay, so I am striking this off, though I have written it. Okay, next one. This will be link or revolute pair between 4 and 1. Revolute pair between 4 and 1. Similarly, this would be revolute pair between 5 and 7. Revolute pair between 5 and 7. Right? Now here it would be revolute pair between 5 and 6. Okay? This would be revolute pair between 1 and 6. Right? Now, moving to this point, that is sliding joint. Here you can see at this node there is link number 7 present, there is link number 8 present, and link number 1, that is ground. So 3 links are present here. So when 3 links are present here, they will be forming a ternary joint. Here you have seen 3 links are present, but you are forming 2 revolute joints. Here there will be a formation of revolute joint between 7 and 8. Between 7 and 8 there will be revolute joint. Between 8 and 1 there will be prismatic joint. Between 8 and 1 there will be prismatic joint. Right? I hope you guys are clear with the counting of joints as well as with the link numbering also. Especially the students are committing the mistake when they do the counting for number of joints. You are required to identify binary joint, it is very easy to count. But if it is a ternary or quaternary joint, then you should recall that how a binary joint, how a ternary joint is converted into identical binary joints or identical number of binary joint. Okay, or how a quaternary joint can be converted into binary joint. That you need to recall, and for that reason you have to be very careful when you are doing the counting for the number of joints. Okay. So number of binary joints will be equal to number of binary joint. Here it would be, that is R12, 2, 3, this is 1, 2, 3, 4, 5, 6, 7 and 8. Both are different in nature. At this node both joints are of different nature, revolute and prismatic. At this node both joints are of identical nature, that is revolute. So here the number of joints would be how much? 1, 2, 3, 4, 5, 6, 7 and 8. 8 would be the number of joints. 8 would be the number of joints, right? Similarly, number of ternary joints, number of ternary joints will be 1, which is identical to 2 binary joints or binary revolute joints. Okay. So here J will be equal to 10. J will be equal to 10. Now number of links are how many? Number of links are, I guess it is 8, right? So now we can apply the cuts back equation. Cuts back equation we can apply, that is H is equal to 0, degrees of freedom F is equal to 3n minus 1 minus 2j minus H. Okay. So here number of links is equal to 3 into 8 minus 1 guys, minus 2 into the number of joints is 10. Higher pair of course it is 0. As such there is no point or line contact between the elements of this mechanism. So it will be higher pair will be equal to 0. So here if you apply, this will be 21 minus 20, that is equal to 1. Degrees of freedom will be equal to 1, guys. Okay. So that is option A is the answer. Option A is the answer. Okay. Now moving to next question. Right. So in this question, a double crank mechanism is given to you. Okay. So for this mechanism, you are required to determine the ratio of time of forward stroke to return stroke. So far in our gate syllabus, our gate questions, we have seen the QRR, the computation of quick return mechanism for crank slotted lever mechanism, for Whitworth mechanism, and for offset slider mechanism. Okay. So this is also one of the mechanisms where we will be computing QRR, Okay. So guys, before going to the QRR, I would really like to recall here some basics also. Okay. So here this is clearly given, it is a double crank mechanism. So we can apply the Grashof's law here and check whether it is correct or not, right. So here the shortest link, that is L minimum, that is equal to 5, centimeters, that is equal to 5 centimeters. L maximum, guys, it is equal to 9 centimeters. Okay. So here, that is Grashof's law states that if a mechanism, if there has to be a continuous transmission of relative motion, the summation of shortest link plus longest link must be less than or equal to summation of other links. Okay. So here L minimum plus L maximum is 5 plus 9 less than equal to, next is 8 plus 7, okay, that is 15. Okay. So 14 is less than 15. So this will be satisfying the Grashof's law, and as per Grashof's law, if you are fixing the shortest link, the result would be double crank mechanism. Okay. Let us just see here some of the animations to understand that. Yes. So here you can see both the input links and the output links are executing circular motion. This is double crank mechanism, guys. Okay. Next one is double rocker mechanism. So in the double rocker mechanism, you will see the blue color link is undergoing 360-degree rotation. So in Grashof's law, at least there should be minimum one link which is undergoing complete rotation. Okay. So one time there was a question asked on the same observation also. Okay. So this is double rocker mechanism. Similarly, this is crank rocker mechanism, which is very well known to all of you. Okay. So here also you will find the input link is undergoing complete circular motion in crank rocker mechanism, whereas in double rocker mechanism you will see coupler link undergoing full circular motion, right. And for double crank you will see the input and output links are undergoing full circular motion, right. Next one. This is, guys, this is non-Grashof linkage. Basically it is not going to transmit continuous relative motion. You can see here, you can realize this from the animation, that it is not going to transfer relative motion. Again, the direction of relative motion or direction of motion is being reversed, not continuous. So this is what we call non-Grashof linkage. Non-Grashof linkage, the law will be L minimum plus L maximum is greater than P plus Q. Okay, this is a non-Grashof linkage, right? So moving to this question, now the fixed link is having a dimension of 5 centimeters, okay, and the adjacent link is 8 centimeter, 9 and 7 centimeters, okay. The adjacent link is 8 centimeters and it is 9 and 7 centimeters. So here you are required to determine quick return ratio. The quick return ratio is, you can determine by getting the extreme positions of the output link. This will be input link and this will be output link. The extreme position of the outer link will be, or output link will be, when it is horizontal. When it is horizontal, and that too towards pointing towards right side. Pointing towards right side. That will be the extreme position of the link. Okay. So whereas the backward extreme position would be, the link will be pointing towards left hand side. Okay. So in general, in order to determine the extreme position of the link for most of the mechanism, especially crank slider mechanism or crank rocker mechanism, will be breaking now. Guys, there was a power failure. Welcome back. So here you are required to determine the extreme positions of the output link. Those extreme positions will be determining by making the output link in horizontal or collinear with the fixed link. In case of double crank mechanism, I repeat, we have done these extreme position or determination of these extreme position in case of crank rocker mechanism by making crank and the coupler link collinear. Okay, but that technique we are not applying here. That technique we are not applying here. The extreme position of this would be when the output link takes up this orientation or this orientation, right? These two will be the extreme positions. Okay guys, so I believe everybody can do this. Once the extreme positions are known to you, the only thing what you are left is to get the angle, to get the crank angle at the extreme positions. Okay, so first extreme position is, that is 9 centimeter link will be horizontal, okay, followed by there is a 5 centimeter link, there is a 5 centimeter link, that is a fixed link guys, that is a fixed link. Similarly, the input link whose length is 8 centimeters will be something like this. This is 8 centimeters and 9 centimeters and 9 centimeters, right? So I want all of you to get the answer for me. What will be this angle? Let us say this is theta 1. Let us say this is theta 1. Apply cosine rule guys and please respond. Please respond guys. Yes, somebody, it will be 7 centimeters. 7 centimeters. Yes, Himanshu, yes, you are correct, boss. You are correct. It will be 7 centimeters. Output link is 7 centimeters. Yes, correct. Right. 7 centimeters. Okay. Yes, Priyansh and Himanshu, you are correct. What will be the value of theta 1? That is 9 square. That is 9 square is equal to 8 square plus 12 square minus 2 into 8 into 12 into cos of theta 1. Cos of theta 1. What is the value of theta 1 guys? What is the value of theta 1? Yes, anybody please respond. Guys, Bharadwaj, Priyansh and aspirant is also there. Okay, anyways, I will wait for your answer and I will do the another extreme position. Yes, it is 48, yes, aspirant and Priyansh, absolutely correct. Your answer is, that is theta 1 is 48.58 degrees. 48.58 degrees. Similarly guys, what you can do is you can find out the extreme position when the output link is in the backward position. Okay, so that is, here the output link will be like this and this will be fixed link. This is 5 centimeters guys and this will be 9, sorry, not 9, it is 7 centimeters. It is 7 centimeters. Okay. Similarly, that is, I guess the, let me just write the numbering here. Yes, this is O1, O2 and this is A and B. Okay, this is O1, O2, right, and from O1 there will be input link. There will be input link and this will be coupler link. This will be A and this will be B. This will be B. Okay guys, so here I need to apply the cosine rule once again. Here I need to apply cosine rule once again. This will be theta 2 guys. This will be theta 2. Okay, so you know very well that is length of the input link is how much? Length of the input link is 8 centimeter and the coupler link 8 centimeter guys, it is 8 centimeters. and the coupler link is 9 centimeters. Apply the cosine rule here. The triangle would be O1BA. Okay. So here that is 9 square is equal to this dimension would be, guys, 2 centimeters. This dimension would be 2 centimeters, guys. So 9 square, that is equal to 2 square plus 8 square minus 2 into 2 into 8 into cos theta 2. So I am waiting for you guys to respond. What will be cos theta 2, or in short, what will be theta 2? What will be theta 2? I guess theta will be greater than 90, guys, for this configuration. Theta 2 will be greater than 90. So what is the answer, guys? Yes, aspirant and Priyansh is active. 113.96. 113.96. This will be the angle in the backward extreme position. Okay, guys. Similarly, now we are required to analyze what will be the angle for the forward stroke and what will be the angle for the return stroke. Okay. We are required to analyze what will be the angle for forward stroke and return stroke. Okay. So I guess I will have to erase this, okay, so that I can draw the extreme positions and draw theta 1 and theta 2 for you. Okay. So I am erasing this, guys. So we got theta 2 as 113.96 degrees. Okay. Now, yes. So this is fixed link. This is fixed link, and this will be other end, right? Now let me just draw the outward, that is when the output link is in extreme position in forward direction, okay. This will be 7 centimeters, guys, and this will be 8 centimeters, and this will be 9 centimeters. You have calculated this angle to be as 48.58 degrees. Okay, guys. Now let me just change the color so that you can clearly differentiate between the extreme position in forward direction and extreme position in the backward direction. Right. So this 7 centimeter link will be exceeding beyond this by a length of 2 centimeters. Okay. So this is O1, O2, this will be A1, and this will be B1. Right. So the point B1 will be exceeding O1 in the left hand side, point B1. So let me write this point as B2. Now here the input link will be taking some orientation like this, whose length is 8 centimeters, guys, and this is 9 centimeters, right? Now, guys, what will be the forward stroke? Okay. This angle you have calculated to be as 113.96. Yes, I see. Okay, Bittu Kumar is also, yes, correct. Now, the angle for the forward stroke will be what? The angle for the forward stroke, guys, you can visualize this and give me the answer. Hurry up. I am waiting for your response. What will be the angle for the forward stroke? Guys, this will be the angle for the forward stroke. This will be the angle for the forward stroke. What we call it as theta F. Yes, guys, can anybody answer this? What will be this angle theta F? Theta F will be the forward stroke and angle for the forward stroke, and similarly this will be the angle for return stroke, that is theta R. Yes, 293 Priyansh is saying. Guys, Priyansh, is it 293? That is 113, that is 113.96, okay, 113.96 plus this angle is what, guys? 180 minus of 48, that is 180 minus 48 means that is 130 approximately. 130 plus 113 is 233 or 234. Yes, I guess Priyansh now it is correct. Yes, now please be careful with your calculations, guys. 113.96 plus 180 minus of 48.56, yeah, this is equal to 245.38 degrees theta forward. Similarly, guys, theta r can be known very easily, that is 360 minus the value, okay, that is 245.38, right? What will be this value? Close to 100, 120 or 115, guys? Yes, 114.62, 114.62, right? So now you can get what is the QRR for this. QRR, quick return ratio, that is theta forward by theta return, approximately this will be 2 or 2.1, I guess. 245 means 114 into 2 is 228. So this will be slightly greater than 2, slightly greater than 2. So I am just approximating the answer VCR. Yes, I am approximating this answer. This is 2.14. Priyansh, he is very active. Yes, thank you. Okay. Right, guys, we will move to next question. So, one, we have the questions expected from this topic will be either a degrees of freedom or quick return ratio or Grashof's law, that is inversions of 4-bar mechanism. Based on that equation, that is L minimum plus L maximum is equal to summation of other links, or greater, less than or equal to summation of other links, what we have seen in the Grashof's law, right? So yes, I think Priyansh, Bittu Kumar, aspirant, all you are correct. Let us go to next question, guys. Okay. Right, guys. So now we will be getting into velocity and acceleration analysis part of this chapter. Okay. So a slider crank mechanism has a crank length of 30 centimeters. Okay. Crank length is 30 centimeters, guys, whereas length of the connecting rod is 40 centimeters, and the line of action of the slider passes through the center of the crank, which means that this is a crank slider mechanism, not an offset crank slider mechanism. Okay. And next is that at the instant, yes, passes through the center of the crank, at that instant the slider is at a distance of 50 centimeter from the crank center. Okay. Right. So the lengths are given to you, guys, not the angles. And uniform velocity, crank rotates with uniform velocity of 60 rpm, guys, 60 rpm. So for this question, first is that we need to draw configuration diagram. So once we are able to draw the configuration diagram, we can use formula method to solve this question, or we can use I-center method to solve this question. Okay. So let me just draw the diagram. Right. Sir, how to visualize this diagram for the calculation? Yes, Priyansh, first is and foremost thing is that what are the link lengths you identify. In the IC engine or in the crank slider mechanism, the primary important dimensions are length of the crank and length of the connecting rod. That's what I have written here. Okay. Next is that Here the line of action of the slider passes through the center of the crank, and that distance is also mentioned, which is 50 centimeters, guys. This is 50 centimeters. Guys, this is a very well known 3, 4, 5 combination will form a right angle triangle, that is 5 square is equal to 3 square plus 4 square. So this angle will be definitely 90 degrees. This angle will be definitely 90 degrees, right? Now you can get this angle theta and you can get this angle phi. Okay, once you are able to get the theta value, phi will be 90 minus theta. What is the theta value, guys? Theta value is how much? Theta is equal to cos inverse of 3 by 5. Theta is equal to cos inverse of 0.6. 0.6 means that has to be 36. Sir, how to visualize these calculation for previous question? Previous question, yes. For previous question, if you are, let me just complete this question and after that I will take your doubt. Okay, Priyansh, please be patient. What is the value of theta, guys? 53.13, 53.13. Okay. If this is 53.13, then phi will be equal to 36.87 degrees. 36.87 degrees, right? Now, yes, you are required to determine the velocity of the slider. Velocity of the slider can be determined very easily if you are using the formula method, that is velocity of piston is equal to r omega times of sine theta plus sine 2 theta by 2n. If you are using this formula, that can be done very easily. Okay, this is one of the methods to get the answer, but I will be focusing more on the eye center method, guys. I will be focusing more on the eye center method. Okay, yes, it is 237 centimeter, that is option A. Option A is the answer, guys. Okay, option A is the answer. So let me just do the eye center method for you guys. Okay, this is 30 centimeters, this is 40 centimeters, this is 50 centimeters. Okay, now you know very well that is, this is crank, connecting rod and slider, right? Now let me just do the eye center numbering. This will be link 1, link 2, link 3 and link 4. I12, this will be I12, revolute joint, so it will be directly I12. Next will be I23, guys, next will be I23. Similarly, this will be I34, right? And I14, or there is a prismatic joint present here, prismatic joint or a sliding action, or the piston is going to move along the straight line. So when the piston is moving along the straight line, its radius of rotation will be located at infinite. Okay, so I14 will be lying somewhere at infinity, here or here, I don't know. Similarly, the I14 will be lying along the line of stroke also. It will be lying along the line of stroke because this is having infinite radius. It is having infinite radius. So when you move to the infinite distance, you will see only this line and this mechanism will appear as a point. When you move to infinite distance, you will see only this line and entire mechanism will appear like a single point, which you know very well. So I14 will be infinite here and here also. Okay. Now you have located how many eye centers? 4 eye centers. The remaining 2 eye centers are to be located with the help of Kennedy's theorem. Okay. So Kennedy's theorem you can apply here, that is 1, 2, 3 and 4. Okay, join 1 to 2, 2 to 3 and 3 to 4. Okay, so 1, 3 can be located, or 1, 3 will be collinear with 1, 2 and 2, 3. 1, 2 and 2, 3. I center 1 3 will be collinear with 1 2 and 2 3. So 1 2 is present here, 2 3 is present here. Extend this line, it will meet somewhere I14 at here. Okay. So 1 3 also has to be collinear with 3 4 and 1 4. 3 4 and 1 4, this is the line, guys. 3 4 and 1 4, this is the line. So this will be I13. This will be I13, guys. Okay. Similarly, you can also locate I24. I24 can be located by joining 1 2 and 1 4. 1 2 and 1 4. 1 2 and 1 4. 1 2 and 1 4, this is the line, guys. 1 2 and 1 4, this is the line. Similarly, 2 4, if you want to locate, the other way is 2 3 and 3 4. 2 3 and 3 4. Okay. So 2 3 and 3 4, this is the point 3 4. So extend this, you will get I24. Extend this, you will get I24, right? Now apply the Kennedy's theorem, guys. Now apply the Kennedy's theorem, right? So if you are applying the Kennedy's theorem, yes, here I can write, here first I am interested to find the velocity of piston, I guess, guys. Velocity of piston or velocity of the slider I need to find. Okay. So what I can do is, guys, velocity of piston is equal to, that is I12. I24 is located here, guys. I24 is located here. So here I can write it as, or yes, velocity of piston is equal to I12, I14, omega 4, I12, I14, omega 4 is equal to I12, I24, omega 2, guys, omega 2. Guys, 1 2 2 4 is infinite, 1 2 2 4 is infinite, so I cannot write this. Instead, I will be replacing this with velocity of piston. This I cannot write. Directly I will be writing as velocity of piston. So now you can tell me the dimension 1 2 2 4. 1 2 2 4. What is this dimension, guys? What is this dimension? This angle we have calculated already as 53.13. Okay, and this angle we have calculated that as 36.87, right? So what will be this dimension? What will be this dimension? It will be slightly greater than 30 centimeters. It will be slightly greater than 30 centimeters. Yes or no? Okay. So that has to be, let me just write this. So this will be 30 by cos 36.86. 30 by cos 36.86. And what is the angular velocity? What is the angular velocity of the crank? That is 60 rpm. 60 rpm, if you convert into radians per second, I guess it will be 6 point change something. 6 point change, it would be, okay, or 6.47 I am writing here, 6.47. So what will be the answer here, guys? What will be the answer? Close to 230 or 240 once again. Okay. Similarly, you can apply this velocity theorem to get the angular velocity of connecting rod. You can apply the velocity theorem to get the angular velocity of connecting rod. So when I am calculating angular velocity of connecting rod, I need to consider the icenters between the link 2 and link 3. I need to consider the icenters between link 2 and link 3. Okay. So let me just do it on this page. So here velocity of, just a minute, guys. Yes. Now Yes. Here I23 will be the point, or it will be a moving point basically, or basically I can say this is the relative eye center, and 1 2 is a fixed eye center, because 1 is the fixed link, 1 is the fixed link, 1 2 is the fixed eye center, and I13 is the absolute eye center of link 3, because when I write here 1 3 or 1 means 1 is the fixed link, so I13 will be absolute eye center, and 2 3 link 2 is also moving, link 3 is also moving. Okay, so 2 3 will be I23 will be relative eye center, guys, it will be relative eye center. Okay, so let me just apply the velocity theorem here. I12 I23 omega 2 is equal to I13 I23 omega 3, omega 3. So I12 I23 is 30, I12 I23 is 30 centimeters, and omega is 6.47 change, I guess. Okay, and similarly I1323, I1323, what is this dimension, guys? What is this dimension? Okay, here you know it very well, this is 90 degrees, this is 90 degrees, right? Now you can apply that is trigonometric ratio to get this value. So this angle will be, this angle is 36.86 or 87 approximately. This is 53 once again, guys, 53.13, and if this is 90, then this will be 36.86 degrees. Okay, so you know that I23 I13 is larger length, and this is the hypotenuse, sorry, yes, this is the hypotenuse. So you can use the trigonometric ratio to get the answer, guys. Okay, you can use the trigonometric ratio to get the answer. Yes, anybody can get the answer? What is the trigonometric ratio I am supposed to use here? Sir, I can solve by rigid body concept also. Yes, you can solve, many methods are available. Whatever is going to save your time, you can adopt any one. Bittu Kumar. Okay. So here let me just write the ratio for you. So that is tan 36.86 is equal to, tan 36.86 is equal to, that is opposite side is 40 divided by the adjacent side, that is 40 by I13 I23. Okay, I23. Aspirant is saying 53.13. Where it is 53.13, boss? This will be 36.86, right? 36.86. You can consider any one of the angle. It is your wish. So here this will be, I1323 will be 40 by tan of 36.86 into omega 3. What is omega 3? Option B, that is 3.53 is, yes, Priyansh is, Himanshu. Priyansh and Himanshu, yeah, Priyansh is saying 3.534 and Himanshu is also saying the same option, that is option B is correct. Precisely, radians per second, correct. Okay, so this is one of the problems from the velocity analysis of the crank slider mechanism, right, guys? Let us move to next question. Yes, this is the question from crank slotted lever mechanism. Okay, crank slotted lever mechanism. One more thing, guys, one more thing. Here the configuration of the mechanism will be given to you in such a way that you will be able to use trigonometric ratios, that is sin, tan and cos, easily, and get the remaining angles in that mechanism very easily. So it is not going to be a complex mechanism. your numerical calculation with reference to computation of angles and the other adjacent link will be easier, because the time allotted to you is 2 to 3 minutes. Okay, 2 to 3 minutes is allotted for the question. So there, I mean, giving the complex mechanism may not be right. Okay, so let us do this question. So refer to the inverted slider crank mechanism. At the instant the input link PS is horizontal and perpendicular to the fixed link. It is perpendicular to the fixed link and has the angular velocity of 1.25 radian per second. Omega, that is omega PQ, you have it as 1.25 radian per second, guys. Okay. The magnitude of Coriolis component of acceleration, this you are required to do. Okay. So first let me, can you calculate the velocity of the crank or velocity of the link? Yes, that is fixed link. Angular velocity is, just a minute guys, this is the angular velocity of link PS. It is PS, not PQ. It is PS. Velocity of PS is equal to, that is 400 into 1.25, which is equal to 500 mm per second, guys. 500 mm per second. Velocity of the crank. Yes. Next, let me just draw the configuration diagram once again here. Right. Now, here if you see the question, the direction of omega, this is omega direction, it is given upwards. It is given upwards to you. Okay, that is 500, and it will be perpendicular to the link. Velocity will be always perpendicular to the displacement vector or the link. Okay. So velocity direction, let me just change the color here. This is VPQ. This is VPQ, PS, sorry, it is PS, it is VPS. Now, this VPS we can resolve in two components. Here on the slotted bar, you can see a slider is moving. Okay, a slider is moving along the slotted bar, and this slotted bar is in angular motion also. So I can resolve this velocity along the slotted bar and perpendicular to the slotted bar. Okay, I can resolve the velocity along the slotted bar and perpendicular to slotted bar. Okay, let me just do that. So this will be one component and this will be another component. And if you see that this component is perpendicular to slotted bar, it is perpendicular to slotted bar, right? Now, what will be this angle? This is 400 and this is 300. 400 is this dimension, 400 is this dimension, and this is 300. Okay, can anybody tell me what will be this angle? Guys, can anybody tell me what will be this angle? Tan inverse of 3 by 4, guys, tan inverse of 3 by 4, that is 36.86. 300 along the bar. Priyansh, 300 along the bar means, what are you trying to say here? What will be this angle, guys? tan inverse of 3 by 4, 36.86. Okay, 36.86. So this angle 36.86, the normal or the normal of this slotted bar will make the same angle with the vertical. This is 36.86. This is 36.86. 300 along the bar. Okay, you are doing the components right. Okay, I got you. This is the velocity of the slider, which is equal to VPS sine 36.86. Yes, absolutely correct, Priyansh. Absolutely correct. This is equal to 500 into sine 36.86, which is 300, guys, which is 300 mm per second. Okay, and this will be velocity of the slotted bar, because slotted bar is in angular motion, so velocity vector will be perpendicular to slotted bar. So V slotted bar is equal to VPS cosine of 36.86. VPS is 500 and cosine of 36.86 is 0.8. So that is 400 mm per second. 400 mm per second, guys. Yes. Yes, guys, please respond. Okay, I am waiting for your response. Now that we are left with only Coriolis component of acceleration. So Coriolis component of acceleration needs to be determined here. Okay, so this is the slotted bar given to you. I am considering only slotted bar, guys. On the slotted bar there is a slider present. Okay, so acceleration is 480. Okay, 480 it is. Let me give you the direction also. Here the slider is moving upwards with a velocity of 300 mm per second. 300 mm per second. Agreed. Next is the angular velocity of the slotted bar will be like this. So omega SL will be equal to VSL by length of the slotted bar, or radial location of the slider also, So the radial location of the slider here for the slotted bar, it is, what will be this dimension, guys? It is 500. 500 is the radius of this slider, correct? So velocity will be radius, this radius into angular velocity, correct? So that is 400 is the velocity of slotted bar, radial location or the radial distance is 500, that is 0.8 radians per second, 0.8 radians per second. Okay, now you have to, to get the Coriolis component of acceleration, you have to rotate V slider in the direction of omega slotted bar by 90 degrees. Rotate this vector V slider in the direction of omega slotted lever by 90 degrees. This is the A Coriolis. A Coriolis mathematically it is given by 2 into V slider into omega of slotted lever, Okay, this is slider, guys. Both are SL, so I have to be careful with the subscripts. So this is 2 into V slider we have got it as 300 into 0.8. that is 1.6 into 300 is 480 per second, per second square, 480 per second square. That is option B. Option B is the answer. Option B is the answer. Okay guys, so we will be breaking now. Priyansh, I guess yes, I was supposed to answer your question. Yes, how to visualize these diagrams for calculation was here in crank rocker mechanism. You, in order to determine the extreme positions of the rocker, you will be making crank and the connecting rod or the coupler link collinear. The input and coupler link must be collinear, but whereas in double crank mechanism you can directly understand B will be, this point B, when it is in extreme position, it will be horizontal or it will be collinear with the fixed link that is pointing towards right hand side, and the same link if it is in extreme backward position or during the return stroke, then it will be pointing towards left side. Okay, so which I have done here, I have drawn two extreme positions. Okay, so for crank rocker mechanism, you can watch this animation. To understand that. Please rerun the video and understand how the rocker is moving to the extreme position. Okay, you can rerun that video and see it. Okay, I'll be moving to next question. Okay, this is another question. The collar C in the figure is moving downward with an acceleration of 1 meter per second. This collar is moving downward with an acceleration of 1 meter per second. At the instant shown, it has a speed, of 2 meter per second, which gives the link CB and AB angular velocities. The angular velocities of input link AB is given to you, and the coupler link, that is BC, is also given to you. So the data relating to velocity analysis is already been given to you guys. Only thing you have to worry is that what is the angular acceleration of the link AB at this instant. This way also the question can be framed. Okay, so please understand that, because in the year 2019 I guess I have seen a question on the acceleration analysis. Okay, for a simple configuration. For the simple configuration only the question will be framed. The configuration diagram will be given you, or the dimensions of the configuration will be given to you in such a way that you will be getting the angle values. Like here 0.2 and 0.2 is given. You will tell definitely, sir, this angle has to be 45 degrees. Like those kind of situations will be given to you in the configuration. Okay guys, so let us move to this question, that is omega AB is equal to omega BC is equal to 10 radians per second, guys, 10 radians per second. Okay, and here, yes, velocity of the piston is also given. But that data is not needed here. Here the velocity or acceleration of piston is given to us, or acceleration of the collar. So acceleration of the collar is 1 meter per second square, right? So now what we can do is, guys, first we need to identify the components of accelerations. Okay, and after identifying those, we will be doing the vector summation. We'll be doing the vector summation. Okay. Okay, guys. Yes. This is the line of stroke of the collar. Okay, and here omega AB is given to you, that is 10 radians per second. That is, this value is 10 radians per second. Okay, AB, this is A, this is B, this is C. Right. Now guys, the component, the radial component, acceleration here will be comprising of two components. Here one will be radial component and one will be tangential component. So radial component will be directed towards the point of rotation, towards the point of rotation. This will be radial component of acceleration. Okay, so that is AR of B relative to A, radial acceleration of point B with reference to A. Okay, so this is the direction. It is in positive J. It is in positive J. Okay, now the tangential component of acceleration will be perpendicular to this link. Yes, but what is the direction? I don't know. I know that it will be along this line only. Okay, so let me just assume that it is acting along the positive x-axis. I am assuming, I am not claiming. Okay, so A tangential of B relative to A. This is given by, or this is in, let us say we have assumed that as positive I. Positive I. Right guys? Now you know very well this angle is 45 degrees. This angle is 45 degrees and the unit vector along BC, the unit vector along BC, let us say that vector BC or unit vector BC, okay, n cap BC can be directly written, guys. Okay, I don't have to worry about this length. Once the angle is known with reference to the axis, I can write directly, and this vector is pointing towards second quadrant, guys. It is pointing towards second quadrant. So I am supposed to write it as I cos 45, I cos 45 plus j sin 45. Okay, minus I cos 45 plus j sin 45, because it is pointing in the second quadrant from the reference point B. Right? Okay. Next, the angular velocity of BC is in this direction. Okay, let it be. Let it be. Now, how would be the direction of tangential component of acceleration of BC? That I don't know. That I don't know. But it will be definitely perpendicular to the link. It will be definitely perpendicular to the link. Okay, perpendicular to the link. I am assuming that it is in third quadrant. With reference to C, it is in third quadrant. Okay, so now this vector will be making an angle of 45 degrees once again. This vector will be making an angle of 45 degrees once again. Yes. Yes guys, please respond here. I will name this as radial component or radial vector, or basically for naming the radial vector we write it as ER cap actually. We write it as ER cap, radial vector, and this is tangential vector. We write that as ET cap. Okay, so this is in third quadrant. I will be writing that as I cos 45 minus I cos 45 minus j sin 45 minus j sin 45. Okay, So now that I have all the vectors available with me, what is that all I need to do is, I need to do sum up the vectors. I need to sum up the vectors. And this the collar is moving, the collar C is moving in downward direction. What is the acceleration? 1 meter per second. Acceleration of point C, it is not E, it is C, is equal to 1 meter per second square, that too in minus j cap direction, that too in minus j cap direction. Now I need to write here equation of motion, okay, for the point C. Okay, for the point C I need to write the equation of motion. Right, now acceleration of C is equal to acceleration of B plus acceleration of C relative to B. Now this acceleration, this part of acceleration will be split into two components once again, will be split into two components. That is radial component of acceleration of C relative to B plus tangential component of acceleration of C relative to B, next plus acceleration of B is equal to acceleration of C. Okay guys, please understand this equation. We are writing this equation of general motion. Okay, link BC, that is connecting rod, it is in general motion. Okay, so for point C I am writing this. Right, now what will be the acceleration of B? Acceleration of B relative to A, or absolute acceleration of B, I can write here acceleration of B is equal to acceleration of A plus acceleration of B relative to A. Okay, anyways A is a fixed point, this will be 0, A is a fixed point, this will be 0, and acceleration of B is equal to, one is the radial component. Radial component, how will you write, how will you express this? This is given as RAB into omega AB square. Guys, RAB is equal to 0.2 and omega AB is 10. So 0.2 into 10 square is 20, 20 meter per second square. Okay. Next is tangential component of acceleration is RAB into alpha AB, guys, into alpha AB. So RAB is 0.2. So this I can write it as 20 meter per second square is in positive j direction. So this is comprising R acceleration of B relative to A will have two components, one would be radial, one would be tangential. So radial is 20 j cap, 20 j cap, next is plus 0.2, RAB is 0.2 alpha AB plus I cap. I don't know this direction is correct or not, I have assumed that. So this is the acceleration vector for point B. Okay, so let me just write here acceleration of C is equal to 20 j cap plus 0.2 alpha AB. This is acceleration of point B. Similarly, radial component of acceleration for link BC or the coupler link, okay, this is, I guess the dimension, this is 0.2 and this is 0.2, this will be root 2 times of 0.2, root 2 times of 0.2. The hypotenuse BC will be root 2 times of 0.2. Okay, so what will be root 2 times of 0.2? Yes guys, what is root 2 times of 0.2? That is 0.28. Yes, what is root 2 times of 0.2, guys? Please respond. So RBC I am writing here, that is 0.2 times of root 2, which is equal to 0.28. 0.28 it is. So 0.28 into omega BC, radial acceleration will be omega BC, that is yes, this is tangential component and this is the vector, for radial component. Okay. Yes, guys, there is a small correction here. Here when we are taking the reference point as B, here we are taking the reference point as B, so the radial component will be directed from C towards B. It will be directed from C towards B. So this direction, this vector has to be modified. The vector will be like this, guys. From C it will be directed like this. It is in the fourth quadrant, so this has to be minus j sin 45. This has to be minus j sin 45. Okay. So radial acceleration, radial component of acceleration of C relative to B, that is 0.28 into 10 square, that is 28 meter per second square. And this will be the vector which is going to define the radial component of acceleration. This will be the vector which is going to define the radial component of acceleration. Magnitude is 28, and the vector will be I cos 45 minus j sin 45. Okay, so let me write that. This is 28 into I cos 45 minus j sin 45. Okay, that is radial component, that is also done. Similarly, guys, a tangential will be, that is, how do we express this? We express this as RBC into alpha BC into ET cap. I have assumed ET cap in the third quadrant and this is in the fourth quadrant. I don't know whether this is correct or not. Once after solving I will come to know it. Okay, so this is 0.28 into alpha BC, 0.28 into alpha BC minus I cos 45 minus j sin 45. Okay, now the vector summation is being done, and this part of the equation here, in acceleration of C, in place of this you can write it as acceleration of C is 1 meter per second square, that too in minus j direction or minus negative y axis, right. So here we need to only rearrange the I coefficients and j coefficients. So this is I cap, guys, this is I cap. So I need to arrange here I and j coefficients. So here I coefficients, there is alpha AB is present here, and in I coefficients there is 28 cos 45 is present, and in I coefficient there is 28 alpha BC. So here what we can do is, first we will collect the j coefficients. Okay, coefficients of j, that is minus 1, and this will be plus 20, okay, plus 20, and similarly here it is 28 sin 45, that is already, I guess this is root 2, RBC is root 2 times of 0.2 into sin 45, so root 2 and root 2 will be cancelled. This will be 0.2 once again, okay, 0.2, just a minute, guys, this is 0.2 into root 2 into 10 square into sin 45. Sin 45 and root 2 will be cancelled, so this will be 20. Okay, so this is 20. What will be the sign here? The sign will be minus sign. sign here it would be minus 20, okay, plus 20 and minus 20. Next is 0.28, that is this is actually product of 0.2 into root 2, okay, into j sin 45. J sin 45 means it is 0.2 once again, that is 0.2 once again, guys. So this will be minus 0.2 into alpha BC, So here alpha BC will be equal to this 20 and 20 is cancelled. So this will be equal to 1 by 0.2, which is equal to 5 radians per second square. The direction assumed for BC is correct. I have assumed that in third quadrant this value is correct, or here I am getting a positive answer or positive value, which means the assumed direction is correct. Okay. Similarly, you can do the coefficients of I. Right, here the coefficients of I are 0.2 alpha AB, 0.2 alpha AB, guys, 0.2 alpha AB. Similarly, next would be 0.2 alpha AB, and this is 28 into cos 45, that is again it will be 20 only, it will be 20 plus 20, because this is actually the product of 0.2 into root 2 into 10 square, which we are getting as 28. So when you multiply with cos 45, root 2 and root 2 will be cancelled. So I am hurry upping that calculation. Next is this is 0.2 into root 2 into cos 45. Cos 45 means it will be 0.2 alpha BC, 0.2 alpha BC. That is equal to 0, guys, because there is no I coefficient present on the left hand side. Okay, so this if we solve, alpha BC is anyways 5, so 5 into this will be 0.2 alpha AB is equal to, this is minus 20 and 0.2 into 5 is 1, so minus 20. This would be just a minute, guys, I think I have made a mistake here. This should be a negative sign, this should be a negative sign here. Here it should be a negative sign. So this is negative value. Okay. So this is plus 20 minus 1 is, that is 19, and it will be minus 19. So alpha AB will be equal to minus 95 radians per second square, that is alpha AB, guys, that is alpha AB. Okay, so here what are the options? Yes, options is not, it is a fill in the blank type. Okay, I hope you are clear. आशीष कुमार सर, यही सब आएगा. For which question you are asking, Ashish? See, the gate questions will be having the concept repetition, but with different possibilities. How that concept can be repeated for different configurations, that I am trying to discuss. Okay, next question. Two identical involute spur gears are in mesh. The module is 4 mm. Module here is equal to 4 mm. And each gear has 22 teeth. So two identical gears means, that is pinion and gear are of same size, having 22 teeth. The operating pressure angle is 20 degrees. Phi is equal to 20 degrees. Next, minimum value of addendum. What is the value of addendum needed here to ensure continuous transmission of motion? What is the value of addendum for the continuous transmission of motion? So if you want to transmit the motion continuously, there should be consistently, the gear should be consistently, or the gear teeth should be consistently in contact. So that will happen only when the contact ratio is greater than or equal to 1. Contact ratio is greater than or equal to 1. So the minimum value of addendum will be when contact ratio is equal to 1. When contact ratio is equal to 1. For this corresponds to minimum addendum. Okay. So you know very well the formula for contact ratio. Contact ratio is given by arc of contact by circular pitch. Arc of contact by circular pitch. This is equal to 1. Okay. So arc of contact is nothing but it is path of contact by cos phi, okay, into circular pitch is equal to 1. Okay. So what we can do is path of contact. Here path of contact formula you can write, and here both gear and pinion are in identical shape. Sorry, identical in number of teeth. Both pinion and gear are having identical number of teeth. So what we can write, path of contact that is equal to small r a square r square cos square phi minus r sin phi plus capital R A square minus r square cos square phi minus capital R sin phi. Okay. So both are identical. This can be written as 2 times of R A square minus r square cos square phi minus r sin phi. Okay, that is path of contact formula. So here contact ratio is equal to that is 2 times of R A square minus r square cos square phi minus r sin phi divided by cos phi into circular pitch is given as pi times of module, which is equal to 1. Okay. So guys, all is that you have to substitute the values and get the addendum value. You have to substitute all the values to get the addendum. Okay. So here R will be equal to mt by 2, that is 4 into 22 by 2, that is equal to 44. Right. Next is, yes, so all the data is available, you have to do the substitution only and tell me the answer. Yes guys, 2 into R A minus 44 square cos square 20 minus 44 sine 20, 44 sine 20, divided by cos 20 into pi times of 4 is equal to 1. Okay, so what is the value of RA, guys? It will be greater than 44. It will be greater than 44, and addendum will be equal to, okay, addendum will be equal to that is RA minus R. RA minus R. Okay, so please answer this. Yes, guys, waiting for your answer. Yes, guys, what is the answer? Yes, 46.35 minus RA. Yes, it is 2. Yes, Priyansh has responded. That is 2.35. Excellent. Excellent. 2.35 mm. Okay. Next question. Yes, guys. In a simple gate train shown in figure, the absolute speeds of different wheels when wheel 4 is driver. You are required to relate the speeds here, guys. I believe everybody can do this question within 30 seconds without my help. See, one relation is that omega is inversely proportional to number of teeth. Yes, Bittu Kumar, 2.35. Right, please respond for this question, guys. Yes, hurry up, hurry up. Very simple question. You can crack this very easily. Yes, guys. Option B. Yes. N4, that is the gear 4. Yes, Priyansh, Bittu Kumar, yes. Other guys, please respond. Yes, the disc number 4 is having greater number of teeth, that is 60 teeth. Obviously, this will be having minimum speed. So, N4 is less than, next higher teeth, next gear with higher teeth is 40. So, N4 is less than N2, N2 is less than N3, N3 is less than N2. Okay, very simple question, guys. So, in the gate examination, you will be having the combination of complex and easy questions also. Complex and easy questions. So, some questions it may take the time more than 3-4 minutes also, but parallelly that balancing is being done by giving a simple question also. Okay. Yes, Bittu Kumar, VGM, Subramanyam, Vignesh, N. Nair. Excellent, boss. Excellent. So your response is more important also. Yes, I am leaving this question for you all guys. Subramanyam, Vignesh, Priyansh, Bittu Kumar, Ashish, please respond. Please respond for this question. Read the statements. Yes, guys. Bevel gear is used for connecting two non-parallel shaft or intersecting but coplanar shaft. Is this statement correct or not? You will be using bevel gear for shaft axis who is having intersection, right? Yes, ABCD, yes, Priyansh is very, very active. Okay. Right, all the options are correct. Yes, bevel gear is used for connecting two non-parallel and intersecting shaft. Option A is correct. Option A is correct. Right. Next is spur gear is used for parallel shaft and coplanar shaft with teeth parallel to the axis. In the spur gear you will find these teeth parallel to the shaft axis. These are parallel to shaft axis. Even option B is also correct. Yes, Bittu Kumar, Priyansh has responded so far. What about other guys? Meteor gear is used for connecting two shafts whose axes are mutually perpendicular to each other and intersecting also. Option C is also correct. VGM Subramanyam. Okay guys, thank you for responding. Helical gear is used for connecting two parallel and coplanar shaft. Yes, two parallel and coplanar shaft. The description of the teeth or the teeth will be cut at an angle. The teeth will be cut at an angle with reference to the shaft axis. The teeth will be having the angle with reference to shaft axis. Because of that angle, the helical gear is going to exert the thrust on the shaft. The helical gear is going to exert the thrust on the shaft. Okay. Ashok Kumar says option B. Ashok, you are supposed to read all the statements carefully, Baba. Whether you like the question or you hate the question, please read everything. And next is helical gear is used for connecting two parallel shafts and coplanar with teeth inclined to the axis of gear wheel. Okay. Option D is also correct. Option D is also correct. Okay. So this is a one of the possibilities in the MSQ type question. Right. Moving to next question, guys. Yes. Here most of the times you will find, yes, Ashok Kumar, okay, Ashok Kumar only has said B. Yes, most of the times in the gear trains you will find the questions coming from the velocity analysis also. So I have added here torque analysis also included. Okay. So before going before solving this question, let us just see the animation also. Let us just see the animation here. Okay. You can see here the ring gear is fixed and the input is given to the arm and output is planet gear is also undergoing rotation. Okay. So here ring is fixed. Now here arm is fixed. This is the arm, guys. This arm is fixed. Okay. Okay, here once again I am repeating this, ring gear is fixed, input is given to arm. Okay, ring is fixed still. Now you can see arm is fixed an input is given to the sun gear. An input is given to the sun gear. Now here input is given to sun gear and the ring is fixed. Okay, so please pause this and rewatch this animation once again to understand the working of epicyclic gear train, guys. So we are fixing the ring first time and giving the input to the arm. Second is that we are fixing the arm and giving the input to the sun gear. Okay, and the third possibility is that you can give the input to the sun gear as well as to the arm, or you can take the input to the, you can give the input to the sun or the ring, whatever you like, whatever you like. Okay guys, so let us get back to the problem. Yes, an epicyclic gear train consists of a sun wheel, stationary, internal gear E, and 3 identical planet wheels P carried on a star shaped carrier C. Okay, the size of different wheels are such that the planet carrier C rotates at 1/5 of the speed of sun wheel. Okay, so here I can say that the speed of the arm is the carrier C. Okay, so speed of the arm divided by speed of the sun is equal to 1/5, guys, is equal to 1/5. Similarly, minimum number of teeth on any wheel is 18. So if you are going to assign number of teeth as 18 to any of the wheels, it has to be minimum should be 18. The other wheels should be greater than 18. That is the condition given here. T minimum is equal to 18, guys. Driving torque on the sun wheel or the input torque, you have given that as 140 Newton meter. 140 Newton meter. Okay, this is the data given to you, guys. This is the data given to you. One thing is that you can solve this problem by tabular method, okay, or you can solve this problem by the algebraic method also. Okay, so let me just do the algebraic method for you. Okay, tabular method, you know it very well. We have been doing that from very long time. Okay, now I have erased the data. So let me just write the equation here. You can see that sun is meshing with the planet gear. I can write omega sun by omega planet is equal to, both are externally geared, and I mentioned that speed is inversely proportional to number of teeth. So I am supposed to write here teeth of planet by teeth of sun. Teeth of planet by teeth of sun. Now if I want to do the algebraic method, here what I can do is, I can replace these velocities of sun and planet with the relative velocities of sun with respect to arm, planet with respect to arm. I can replace that directly. Okay, just to simply write omega s minus omega arm by omega planet minus omega arm is equal to minus Tp by Ts. This minus sign is because of external gearing. This minus sign is because of external gearing. Next is, here you have that, yes, planet is meshing with external gear, sorry, internal gear E, and here internal wheel E is fixed actually. Internal wheel E is fixed actually. Okay, so here what I can write it as, yes, omega planet minus omega arm, omega planet minus omega arm divided by omega E minus omega arm, minus omega E, 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 minus omega E is equal to here it is inversely proportional to teeth, TE by TP, TE by TP. These are the velocity equations, guys. These are the velocity equations. So now the data is given to us, that is speed of the arm. Speed of the arm is 5 times the speed of the wheel S, which means omega arm is equal to, or omega S is equal to 5 times of omega arm, right? So what we can do is, yes, okay. So here we can write omega S minus omega arm by omega P minus omega arm, okay. This is equation number 1 and this is equation number 2. I am multiplying equation 1 with 2. I am multiplying equation 1 with 2. Okay, this is 1 multiplication with 2. So omega P minus omega arm by omega E minus omega arm is equal to, this ratio will be minus Tp by Ts, and this ratio, both, yes, planet and wheel, internal wheel, are internally geared, so both will have same direction of rotation. Both will have same direction of rotation. So that is minus, or both will have same direction of rotation. So here it is omega E, this will be Te by Tp. So this and this will be cancelled out. This and this will be cancelled out. And you know that omega S is 5 times of omega arm. Okay. So this is omega S is equal to 5 times of omega arm, which is already mentioned in the question. Right. So what I can do is I can substitute here 5 omega arm minus omega arm divided by this would be omega E is 0 and this is omega arm, right, and this is equal to minus Te by Ts, So here omega arm will be cancelled, so this will be equal to Te is equal to 4 times of Ts. Te is equal to 4 times of Ts. Okay guys, Te is equal to 4 times of Ts. Now what I can do is, minimum number of teeth has to be 18. Okay, so I can write the summation of radius for this, that is radius of E is equal to diameter of planet plus radius of sun. Okay, so I can write radius of E is equal to diameter of planet plus radius of sun. So if you transform this into summation of teeth, this will be Te, and this is diameter, so it has to be 2 times of Tp, plus Ts. So I don't know where to assign this 18, to the planet or to the sun, that I don't know. So let me just write here Te is equal to 4 times of Ts, and the Ts will be shifting here to this side, okay, and this is equal to 2 Tp. So here this is equal to, Ts is equal to, that is 2 by 3 times of Tp, guys. Ts is equal to 2 by 3 times of Tp. So if I assign Tp as 18, then guys Ts value will be 12. I need to keep the 18 teeth here. Okay, so here from this relation, okay, if I put TS is equal to, or TP is equal to 18, if I put, TS will be equal to 12. So I am here, the condition is that minimum teeth in that train should be 18, not 12. So here I am supposed to assign T minimum to TS, that is equal to 18. Though in the diagram they may not be looking, I mean S is looking bigger than P, that's a trap. That's a trap. Please think carefully. Please perform mathematics carefully. Okay. So here TS is equal to 18 and TP is equal to 3 by 2 times of TS, which is equal to 1.5 into 18, that is 27. Right. Next is TE is equal to 4 times of TS, that is equal to 4 into 18, that is equal to 72 teeth. 72 teeth. Okay guys. Next is, we are required to do here torque analysis. We are required to do here the torque analysis. Okay. So here I can write torque at output into omega of output is equal to torque at input into omega of input. Omega of input. Guys, torque at output is not known, but input torque is known to me. That is, how much it is? 140. Okay. And what else is known? Yes, we can express the ratio because omega arm is the output here. We are fixing the E wheel and you are giving the input to sun, okay, and fixing the wheel. Output will be at the arm. Output will be at the arm. Okay. So now that is T input is equal to 140 and omega input is nothing but sun, omega sun, okay, divided by omega output is omega arm. This ratio guys, this ratio is equal to how much? This ratio is equal to how much? We have just now done that ratio guys. What is this ratio? 1/5, 1 by 5. Omega sun by omega arm is equal to 5. Right? So here we'll be getting this as omega torque at output is equal to 140 into 5, that is equal to 700. Okay, that is equal to 700 Newton meter. Okay, and what is that we are required to find out here? Minimum number of teeth. Driving torque is there. Okay. So here we will be finding the fixing torque guys. We will be finding here the fixing torque. We will be finding here the fixing torque, that is T output plus T input plus tau fixing is equal to 0. Input is given to us as 140 and output is 700 guys, and T fixing is to be calculated. So T fixing will be equal to 840 minus 840 Newton meters. Okay guys. So use this coupon code to get the discount of 20%. So with this we are going to close the session. So happy new year and all the very best for your exams, guys.